Alright, so we just talked about how debugging should be done with the scientific method, and we concluded that with me asking you to think about what makes a good hypothesis and what makes a bad hypothesis. Before I tell you what characteristics make a good hypothesis, let's see a few examples. We fail a test case in which our program crashes instead of producing its correct output. As we debug, we form the hypothesis, my program crashes if the input is too long. What do you all think of this hypothesis? Is it good or does it need some improvement? How could we improve it? Take a second, feel free to pause the video and think about it. What if we instead had the hypothesis, my program crashes if the input is more than 200 characters? Hopefully, you all agree that this hypothesis is better than the first one at least. Can you say why this hypothesis is an improvement? Should we need to improve it even further? Now, suppose that I have this hypothesis instead. My program crashes if the input is more than 200 characters because on line 57 of parseInput.py, I have a fixed size 200 element buffer. What do you think of this hypothesis? Hopefully, you think that this last hypothesis is really good and is quite a drastic improvement from the first hypothesis. Now that we have seen these, let us think about why they are each getting better and state the characteristics of a good hypothesis. Here are three characteristics of a good hypothesis. The first is that the hypothesis is clear. It has to say precisely what we think is happening. The second is that the hypothesis is testable. We have to be able to conduct experiments to refute the hypothesis if it is not correct. The third characteristic is that the hypothesis should be actionable. That means that if we accept the hypothesis, we should be able to do something useful. If we go back and look at our three examples now, we will see that the first hypothesis does not meet any of these criteria. What exactly is long? Because this hypothesis is not clear, it is also not testable. If I run this on an input of 150 characters and the program's behavior is correct, do I reject the hypothesis or continue testing it? I have no idea when to reject the hypothesis because it is too vague to know exactly what it means. The second hypothesis is much better in that it meets the first two criteria. It is clear and testable. We can run the program with more than 200 characters, exactly 200 characters, and fewer than 200 characters. If the program always crashes on more than 200 characters but works on shorter inputs, we can become quite confident in this hypothesis. But this hypothesis is not actionable. Even if I accept that this hypothesis is true, what do I do about it? The third hypothesis here meets all of these criteria. It is very precise in its description of the problem. You can certainly test this hypothesis too. You can see that it works at 200 characters. It doesn't work at more than 200 characters. You could find out that it's crashing on exactly this line. You could look in the code and see that this has the fixed size 200 element buffer we described. Then, if you accept this hypothesis, you can do something useful about it. You know exactly what's going on in the code, or at least believe you know with very high certainty. And you can go figure out how to handle this situation, such as replacing the fixed size 200 element buffer with something that can handle any amount of input. Now, let us talk a little bit about testing a hypothesis. Suppose that instead of programming, we were doing biology and we wanted to study hamsters. We have a hypothesis that hamsters prefer to eat carrots instead of apples. So we set up this experiment. I put out a carrot, I put out an apple, and I let my hamster loose to see which food he prefers. He runs over to the carrot and eats it. So now I accept my hypothesis, right? Hopefully you said, no, of course not. What is wrong with this experiment? How can we improve it? Take a moment to pause the video and think about this problem before you continue. One problem is that there are other variables that may confound us. For example, the distance from the hamster to the carrot is shorter than the distance from the hamster to the apple. The hamster may not care which he eats, he just picked whichever is closer. Another confounding variable is the amount of food. Here we've put several carrots and one apple. It could be that the hamster cares less about which type of food there is and more about the quantity. If we try to space the food out evenly and put the hamster in the middle, we could still have a problem that our hamster is facing one way at the start of the experiment and just goes in that direction. Another big problem with this experiment is that we've drawn conclusions about all hamsters from this one hamster. Maybe this hamster likes carrots, but in general hamsters have no preference. Who knows? We also draw a conclusion from running just one experiment. Maybe this hamster doesn't care about the food type and just picked one. If we ran the experiment multiple times, we might see different results. Lastly, our hypothesis is not very specific. Apple and carrot are actually pretty vague. There are many varieties of carrots and even more varieties of apples. Our hamster might, for example, really like green apples, then find carrots to be okay and not like red apples at all. So how does this relate to programming? First of all, other variables might confound us in testing our hypothesis while debugging. If we go back to our hypothesis that more than 200 characters causes a problem, we want to test it by changing as few other things as possible. If we test with a case that has 200 characters that were all letters and work fine, but then test with 201 characters that have letters, numbers, and special characters like punctuation, do we know if the problem was the 201st character? Or if the problem was something in how we process the numbers and punctuation? Another of our problems was drawing conclusions about all hamsters from one hamster. We might have a similar problem in programming of drawing conclusions from a single input. We frequently want more than one test case to become very confident in our hypothesis. However, a big difference between hamsters and programs is that we can observe the inner workings of our programs via print statements or the use of our debugger. If we put a print statement before and after a certain function and see the first print but not the second, we can be very confident the problem happened inside the function in between them. The last problem we discussed with our hamster experiment was drawing a conclusion from a single run of the experiment. A big difference with programming is that many programs are fully deterministic. When you run them multiple times, they do the exact same thing every time. This is not true for multi-threaded programs which do multiple tasks at the same time. We are not going to cover multi-threaded programs in this course, but their non-deterministic nature makes them quite difficult to debug. We hope that you now have a better idea about what makes a good hypothesis and some pitfalls to avoid when trying to test a hypothesis.